All right, I think you guys can hear me. Good afternoon. Thank you for being here. Today we're going to talk about Kubernetes. I'm very happy we have so many people here compared to my friends over there. And quick intro. My name is Shang Xian and I am a solutions architect at AWS. In the specialist team, my specialty is development technologies, including like serverless containers and some DevOps stuff like CICD. So let's get started. So every time when I talk about EKS, Kubernetes, I always have a lot of people have experience already, either run Kubernetes on-prem or on some cloud or on AWS. And some people just get started, like beginners. So I'm trying to balance a little bit. For the agenda, I'm going to talk about Kubernetes very quickly, just refresh memory for people like already familiar with like Kubernetes. And I'm going to give an overview about EKS, talking about our capabilities, the features. Then I'm going to talk about different components, the control plane, the work nodes, networking, and if you run EKS, what kind of a best practice and the tips, like something you need to pay attention to. All right, so very quickly. So for folks who are not familiar with Kubernetes, initially it was developed by Google based upon some internal product like Borg from their side. Then they actually sort of like donated the project to CNCF, Cloud Native Computing Foundation. So that's now an open source project with a lot of like developers contributed to Kubernetes. It becomes really popular because when you run a Docker container, a dozen, pretty straightforward, very easy. But when you want to run like hundreds of them, you want to orchestrate them, better utilize your resources, especially in cloud, it'll be very challenging. So then you need some orchestration applications to help you. We do have something called ECS, before EKS, allow you to run containers on top of it. And we now have a service called Elastic Container Service for Kubernetes, which is basically allow you seamlessly run your containers, which you typically have them in a pod. That's a terminology in Kubernetes. And you create like a service, then you do deployments in Kubernetes. So why that's important? Because when you do Kubernetes in the cloud, you can really utilize all the cloud capabilities. We're talking about something like cloud native applications, talking about you can utilize like load balancers, and you can utilize all the like security controls. Comparing to run Kubernetes on-prem, it's really challenging. You either have to use like kube ADM or kube spray and stand up your clusters and manage all the storages. When you really operate Kubernetes, you really need a solid foundation. That's why we try to deliver to you. Only with cloud platforms and with cloud applications, you really can allow your developers and users to better utilize all those capabilities. So we do have a lot of experience. Just quickly, we have the number from CNCF survey. They do like annual survey. We do have like 51% of Kubernetes workloads on AWS. And we do contribute a lot back to the community. So if you look at these charts, like, we also run a lot of like containers, billions of them on AWS. ECS, EKS, and now we have the new addition like Fargate, which is a serverless offering. So that's just my quick brief talk about Kubernetes. Then let's talk about EKS. So for EKS, currently, we provide a control plane for you, which means you still have to manage your work nodes, which I'm going to talk about a little bit more. We have some core tenets. So one of them would be, it's supposed to be really production ready and high quality. And we are also 100% compatible with upstream, meaning if you have Kubernetes containers running on-prem, on other vendors, on other cloud, you can seamlessly migrate to EKS. We actually don't force you to use our services. You can choose different building blocks. If you don't like our load balancer, you can choose open source package like Nginx. If you have like F5, you can use F5. And we also actively contribute back to the project. We are now one of the biggest contributors for Kubernetes, and we also do a lot of other projects. It's really straightforward. We provide some APIs, allow you just create a cluster. Then you're going to get an API endpoint. Then you can just talk to the API server and do all your normal Kubernetes like magic. Typically, people use a kubectl to apply a YAML file, just create the deployment, create your pods. Since it's enterprise level kind of product, we do have like, for example, service level agreement. Right now we provide like 99.9 uptime, which usually considered very good in the hosting industry. And we also allow you to easily get your product application certified because we're already taking care of the underneath infrastructure. So for EKS, we already got like a HIPAA compliant, we got a PCI compliant, we got all those like SOCs. We're also working on FedRAMP. We are trying to deploy the EKS into GovCloud. So if you have like your regulatory workloads, then it will be a lot easier for you to just migrate to EKS. So talking about all those components, first, the control plane. So for people working with Kubernetes, you're probably familiar with the idea about like masternodes, which actually host your API server and a bunch of controllers. That's something we provide for you. Underneath is worknodes. Sometimes we call it data plane, which means you still have to create your auto-scaling groups and checking those worknodes into the cluster. If you look at the charts, we do provide a capability allow you to working with multiple auto-scaling groups, which means you can have reserved instance, your spot instance, your instance for different types, like GPU, more memory intensive, CPU intensive instance types into different auto-scaling groups and working in your cluster. Dive a bit deep into the control plane. That's not really visible to you, so it's managed by the production team. The service team actually is making sure we have redundancy for your control plane. By default, we stand up multiple instances for your etcd, which is the key value data store in Kubernetes. We also make sure we have a multiple instance running for your master nodes. So if anything happens, the auto-scaling group over the managed service VPC will make sure that instance would come up and replace the defect ones, for example. So it's highly available, highly redundant, and it also uses all our native components. Like for example, we're using network load balancer in front of like EC2 instances. So we have the capability to monitoring all those components and make sure everything works as expected. One challenge for the Kubernetes is the upgrade versions. So our commitment is support like 3 versions, main versions. Currently we support 1.10, 11, and 12. We actually just had an announcement we're going to deprecate 1.10 on July 22nd. We're going to support 1.13 very soon in this month. Upgrades, the control plane is really easy for you. It's just like a button, then you wait a few minutes, it can be done. Upgrades, the worknodes actually is more challenging. So I'm going to talk a bit more about the worknodes upgrade. When you do the control plane, when you stand up an EKS cluster, something you need to think about. Like for example, you have to think about your VPC size. The reason being is right now we only support the VPC network mode. for folks with experience, Kubernetes has some certain requirements for the network. For example, it has to be flat, right? There's no additional hops between pods to pods. Then usually people use overlay network, Calico, with nets. But on AWS, we do have our overlay network, which is a VPC. So we come up with the network plugin, allow you to utilize the VPC capability, meaning you can attach secondary IPs to your pod. And then you can enable something like your VPC flow logs, you can attach security groups, then you can do a lot of good things. The biggest benefit would be performance. So we don't have the overlay network on top of VPC. You have much better performance just using the VPC network plugin. Then you can deploy your pods in a public or private or both subnets. So that's something I already mentioned. A few weeks ago, we released a blog post talking about our commitments for version upgrade. So the cadence would be around the neighborhood of 90 or 130 days, we try to release a new version, which we try to follow the upstream Kubernetes. So every time they release a new version, we're going to do some testing, make sure the quality is good, then we're going to release a new version. The deprecation means you cannot spin up new cluster for the new version. But if you still have the old version, you're fine. You can still run it for some times. But of course, you're going to lose all the security fixes or the patching. We also have something called platform versions, meaning when we have some security fixes, we discover some critical vulnerabilities, or we have to, for example, add additional capabilities on top of EKS, we're going to release platform versions. One example would be a few months ago, there's a denial of service vulnerability. Then we released a patch and upgrade one of the platform versions for Kubernetes. The nice thing is that you don't need to do anything. It's transparent for you, and your service, your application is not going to be disrupted. Then you always can have the latest version about the API server, the control plane. That's a screenshot about the platform versions. You can look at our website. We do give you all the release notes. Then we do specify all the enabled capabilities, the API server flags, for example, or the admission controllers we allow you to run. Yeah, one caveat is because we have the control and we own the control planes, so you really cannot install or open any flags on the control plane. So you have to sometimes, for a plugin, you have to install on your work nodes, for example. In order to give you a smooth experience to upgrade, we do create an object in Kubernetes called Update Class Version API. You can query this API to list all the updates and describe the updates if you need to. So the other thing I want to talk about is how to do authentication and authorization. As folks with experience knows, in Kubernetes, you have multiple ways to do authorization and authentication. Popular way would be just use RBAC, role-based access control. We want people to have a smooth experience if they want to transition or migrate some workloads from different cluster or different vendor to our cluster. We don't want really them have some outage or do a lot of legwork. So we give you integration with our IAM, Identity Access Management Service. So what you do is you either can install a plugin, or you can actually now can use CLI. That's a pretty new release a few weeks ago. It's going to generate token, basically write your request, send as a token to the EKS service. EKS service is going to pass this to IAM. Actually, underneath is the STS, our token service, to make sure that's the correct user and get the identity back. Once it gets identity back, it's going to pass to the Kubernetes. Then it's going to verify the roles based upon the config map. So it will do some RBAC controls. Make sure you do have the permission to working on something, like for example, deploy a bunch of pods. So that's how it works underneath. One caveat is the first time when you create a cluster, the user would be automatically have the system master, which is like sort of like admin users in Kubernetes. So if you want to add additional users or IAM roles into the Kubernetes, you need to create those roles or users in IAM, then change the config map to add those users or roles into Kubernetes. So before I move to workloads, I would also like to talk about resource sharing. So a lot of times my customers asking, yeah, I have this Kubernetes cluster, I have sometimes hundreds of workloads, how I'm going to divide all those resources into different teams, how I can have like isolation among those workloads. So you need to think about it in different levels. The highest level for isolation would be accounts. So if you have different accounts, they are totally separate. Then of course you can separate based upon clusters. You can create additional clusters. Sometimes it's not desirable if you have like a dev team or QA team, they want to share the resources. So you can also use a namespace to create sort of like a virtual cluster for your Kubernetes cluster. So that's some options you can choose. Okay, let's move to the workloads. One capability or benefit we give to you when you run Kubernetes on AWS is the instance types. We have a variety of instance types allow you to do different workloads. Like for example, we have those like GPU-based P2, P3 instance for deep learning, machine learning. Actually, after we released the EKS, one surprising thing we've discovered is a lot of customers actually utilize EKS for machine learning and deep learning. So that's very popular workloads. And you, of course, can also use like spot instance to cut your cost. Spot instance is sort of like a bid-based instance types. We have a spot market. You can specify what kind of price you want, and usually it's much lower than on-demand instances. So you can mix them together and put them into different auto-scaling groups, for example. We do have reference architectures. We do have open source packages on GitHub, allow you to quickly come up with different auto-scaling groups and for different instance types. A lot of times, our customers also want to create their own image. The reason being could be like you have dependencies, or you have some like legacy applications you want to package with your containers. You can do that because we open source our machine AMI, Amazon Machine Image scripts on GitHub. So it's pack script based. It's our source of truth. So we support Amazon Linux Autobox. And if you want to use like CentOS, if you want to use like Red Hat Linux, you can do that. If you look at the source code, basically we do some scripting, we do some bootstrapping for you, then we package some dependencies for you. Like for example, install daemons, install a kubelet. So you can do the same thing if you want to choose different like flavor of Linux. If you want to use GPU-based machine image to bootstrap your workloads, you really don't need to do this all by yourself. We do have a marketplace which already pre-packages the TensorFlow, Kubeflow, and all those like drivers for GPUs for you. So you can just grab it over there and just stand up workloads. So when you have the workloads, how the cluster knows it has a permission to join the cluster, you do have to change the config map to have the IAM role attached to workloads in the config map. Then when it runs, the cluster knows it has a permission. You do have the option or capability to create some user data. If you're familiar with the EC2 instance, you can have a user data script which can do a lot of different things. Like for example, you want to limit how many pods running on this particular workloads. You can do that when you stand up the workloads in the user data script. You can specify those type of things, which actually invoke a bootstrap script. As I mentioned, upgrade to a new version would be challenging. So Kubernetes moves really fast. They constantly have new versions. You cannot really wait too much time. The reason being is if your Kubernetes version or your client is far behind, you cannot really jump, for example, from 1.10 to 1.12 or 1.13. You have to migrate or upgrade one by one. It would create a lot of burden or backlog for you. So we really recommend that you follow the new versions and upgrade as soon as possible. As I mentioned, for the control plane, it's really easy. You have a toggle, you have a button, just upgrade, and you wait a few minutes, it's done. For the work node, you have two options. One would be you create another auto-scaling group, create all those work nodes, check into the cluster, and you tent. Basically, you tell the control plane that all the old work nodes in the existing auto-scaling group would be tent. They're not going to take new parts from the control plane. Then you start migrating, you basically kill all those pods, right? Then the new pods will be stand up in your new auto-scaling group. The other option would be in-place upgrade, meaning you have one auto-scaling group. Then you just create a new work nodes with a new version, and you're going to kill all the old pods. When they're done, you kill the work nodes. It's faster, but it's not as safe as you create additional auto-scaling group, migrate everything over. So you do have a choice over there, depending upon your workloads, the environment, like a dev versus prod. Let's talk about network. So network is a big topic in Kubernetes. You have a lot of choices. Even for the network plugin, you actually have a dozen choices if you run your own Kubernetes. First, I want to talk about the control plane and all the endpoints. Initially, in the past, when we released Kubernetes, the endpoint, which means when you have the kubectl or kubectl, whatever you call it, when you apply a YAML file and deploy some pods, you need to talk to the API endpoint. Initially, it was only public available. Now we have the capability allow you to make it private, meaning only your VPC can talk into the API endpoint. You can also do VPC peering or use a direct connect or VPN talking to this API endpoint. You can also make the endpoint either public or private at the same time. So when you do this, you still can have the customers, your users, talking to the API point from their laptop. Then the work nodes or your instance inside your VPC can talk into the private endpoint. If you only do the private endpoint, the downside would be the DNS names can only be resolved by a private zone. So you have to create some private endpoints for your Lot 53 private DNS zones. So there's a little bit tricky things over there. We do have a blog post talking about that. If you want to do this, you can look up. So for the VPC network, we open sourced the CNI plugin for Kubernetes running on EKS. The idea would be we allow the plugin to allocate secondary IPs for your VPC fabric to each pod, meaning each pod can have its own IP address. It could be even a public IP address, so you can even expose the service directly from pod if you choose to. There's some limit on the IP space, right? So that's why I mentioned you have to plan your VPC side blocks. There's also a limit on how many network interfaces one EC2 instance can have. So that's something you need to think about. Sometimes if you have a lot of pods working, you might hit the IP exhaustion issues. We do allow you attach additional side blocks into the VPC, and it can be 4 additional IP ranges attached to a single VPC, then your pod can utilize all those available IP addresses. So that's just a diagram shows you if you have a hybrid workload, if you have some workload in your colo facility or in your own data center, you can go through the VPN or direct connect and talking to the pods running in your VPC. Give you a lot of flexibility over there. The other thing I want to mention is that sometimes our customers do have the requirement to have a fine-grained control of the network traffic. So for us, if you're working on the work nodes, you do have the option to attach a security group into the EC2 instance, which give you the control about how the network should be blocked or accepted. If you want to control the network traffic among the pods, we actually collaborate with Calico. You can utilize their plugin to have a network policy control, meaning you can set up all those like sort of firewall rules among your pods to control which pod can talk to which. So for example, if you have your web pods only should be talking to your application pods, you can set up those type of network policy. Then they cannot really talking to any like database pods if you have some. Load balancing. So we do support all our load balancers natively for EKS. You can choose our classic load balancer or network load balancer or application load balancer. As I showed here, you just need to annotate in your YAML file when you have the pod specification, right? You specify it's a load balancer, then in AWS, when you stand up the pod or your service, it knows it needs a load balancer, and it's going to provision for you. If you annotate as a, like for example, NLB, it knows it can provision a network load balancer for you. Another popular choice for Kubernetes is Ingress traffic. So Ingress gives you a lot of nice capabilities, like for example, to do TLS termination, to do traffic shaping, or a bunch of different things for your service. Out of box, we support application load balancer for Ingress, but you do have choices. For example, you can utilize Nginx or HA proxy as your Ingress controller, right? If you want to deploy your application on AWS as a cloud native applications, we highly recommend to take a look at our ALB Ingress controller. So when you create the Ingress object, it will not do anything. You need a controller to allocate the resources for you. It's production ready, it's open sourced. So we have tons of customers using ALB as an Ingress controller. So you can do like path-based routing. Then if you find issues, it's open sourced, then you can raise the issue over there. We have teams actively monitoring the GitHub repository to help you address all those issues or even answer your questions. So just want to give you an example how it works. Here, we have like 2 applications running. Like on the left side, I have like a purple line dictating like application running / share creators, and the other side cheeses. When you have the ALB Ingress controller running, that's not working. So when you annotate, you need the Ingress objects. The controller is going to provision an application load balancer for you if there's none. For the nodes, you can have options to choose either a node pod, which is typically used on Kubernetes, or you can choose like an IP mode. So for the node pod, if you choose like an instance mode on the left side, it's going to use the instance attached to your target group on application load balancer. When you have the green application up running, you do have the choice, like for example, choose IP mode, which give you better performance, and you can enable, like for example, blue-green kind of deployments, right? When it's up, you can do some testing, and when it's finished, then you can flip them, attached to different CNAMEs, for example. So that's my brief talking about network, all the capabilities we have for the load balancing. Storage is also very important and challenging. So on-prem, when you have a cluster, if you have like 10 storages, you have to really be careful how you're going to provision all those like volumes for your clusters. It's not easy. You like add additional hardware into your on-prem cluster, for example. But on cloud, you do have a lot of like flexibility over there. In Kubernetes, how it's being done is typically in your deployment, in your service, on your pod, you make claims for persistent volumes. And underneath, you can create an EBS volume, for example, on AWS attached to the PVC, the persistent volume claims. Even better, you actually can create different storage classes, allow EKS to dynamically provision all those volumes for you. It's really useful if you have a stateful sets. For example, you have a database workloads running on Kubernetes. You want the data to be persistent. When the pod or the workload is dead or it's gone, you want it back to mount the same EBS volume, for example. And we do also support EFS volumes if you need a network file system. So you can provision an EFS volume attached to the pods. The nice thing about EFS volume is it across like multiple availability zones. It's not like EBS. If it states availability zone A, you cannot really mount or attach to a workload on availability zone 2. So that's something you have to be careful. We do have a variety of different storage types. Like for example, we have the generic SSD-based GP2 type. We have high performance. You can provision I/O ops for you. If you run database workloads, those are storage types you want to look at it. Then we have storage type for like a lot of hard disks, cold storage. The nice thing is you can create all those storage classes, and you can also specify a default one. When you need additional volumes, EKS is going to look at the storage class and provision a new volume for you and attach to your pod. So the other thing I want to talk about is auto-scaling. That's really a benefit running Kubernetes on cloud because you can add additional computing capacity easily into your cluster. So there are two levels auto-scaling. One is scale your pods. So for example, you have a lot of application pods running in your cluster. Suddenly you have something going viral. You have a lot of events, traffic coming in, hit your application servers. Then based upon the metrics, EKS can add additional pods into your cluster. Of course, to enable this, you need metrics. So you need something like a metrics server. That's a plugin installed in Kubernetes. However, when you have enough pods, eventually you're going to run out computing resources. To scale additional pod would be not possible because you probably only have like maybe a dozen workloads in your cluster. At that point, you can enable the metrics. You can enable some alarms, allow the cluster scaler, we call it like cluster auto scaler, to add additional workloads into your cluster. how it's being done is you set up alarm, then you send to the auto-scaling group, then based upon the metrics and the alarms, the auto-scaling group is going to add additional EC2 instances into your cluster. Again, those instances could be different instance types. One caveat is scaling up actually is really smooth and nice. When you scale down, you have to pay additional attention. So scale down pods would be still straightforward, but when you get rid of like additional EC2 instances, if those pods are still doing work, then you somehow have to drain them. So we do have a reference architecture and open source package on GitHub to allow you easily just set this up. One option would be you use some like Lambda functions to check if the pod has additional like work. If it's not finished, then it's waiting for a little bit, just blocks the EC2 instance being killed. If the work is done, then you can just let auto-scaling group to take care of shut down the instance. With all those components, it will easily allow you to, relatively easily to set up clusters and migrate your workloads. But again, a lot of times your developers would have adopt some like DevOps processes. They want like CICD. They want to how they're going to monitoring, look at their workloads, troubleshoot. So the complexity about Kubernetes is the ecosystem is huge. You have a lot of choices. So which one to choose sometimes is a tough choice, really depending upon your workloads, depending upon your experience, your skills, then sometimes personal preferences. Like for example, if you do CI/CD, we do support like Jenkins. If you're a Jenkins shop, you already have a lot of Jenkins experience, you can do that. A popular choice would be Spinnaker. So we do have a blog post talking about how you're going to deploy Spinnaker, which is a popular CI/CD tool to deploy your Kubernetes workloads. It also gives you a very nice capability to monitoring your cluster or your pods. And of course, natively, if you choose our service, like our code pipeline, code commit, code build, all work seamlessly with Kubernetes. So you can have like cloud native kind of options for your CI/CD. We also have a variety of like partners. Like for example, we support GitLab, we support CodeShip, Circuit CI, Shippable, all those available choices for you. And at very high level, when you do CI/CD, it's like this. So I choose our services. You can easily replace all the building blocks. Like for example, if you don't want to use code build, which is our managed service for build your applications, you can choose like Jenkins, right? Spinnaker also can be used in this workflow. So this workflow is sort of like people talking about GitOps or Git workflow, meaning you have a code repository. When you finish the change, the developers, when they finish their change, they commit, they push to the repository. And the repository is going to kick off some compilation, the build of your packages, and create an image, doc image, and push the image into some registry. For us, it will be ECR, Elastic Container Registry. Then once it's available in ECR, you can use code build or even use a Lambda to invoke a deployment, pull the latest image from ECR and deploy to Kubernetes. So you're going to have a new version. So before I close up, a lot of times people ask how I'm going to get started. Honestly, initially when we release our service, it's not really straightforward. You have to create a cluster, then we have CloudFormation templates. We actually have a bunch of menu steps, ask you to download the kubectl, which has IAM Authenticate built in. Then you have to download additional binaries. You have to stand up workloads with CloudFormation. You can still do that. A lot of people use a Terraform or use their own scripting mechanisms to automate all those steps. And now we do have another choice. You can use EKS CTL, which is actually from a partner initially, and we support this now. You can just run EKS create cluster. It will do some opinionated choice based upon best practice, stand up your work nodes for you, and check into the control plane. Another choice I want to mention is AWS CDK, which will be GA very soon. CDK stands for Cloud Development Kit, which allows you to use programming language like TypeScript, JavaScript, Python, Java to program your infrastructure and provision them via CloudFormation. It gives you all those type-based check, auto-completion, which is really nice compared to CloudFormation or Terraform. And at last, we have workshops to do. That's developed by a bunch of essays in AWS. Give you a lot of labs to choose. For example, if you want to run Grafana with Prometheus, you can do that. If you want to work with CICD or some stateful sets, you can look at workshop. We do have labs over there. You can borrow a lot of scripts or templates from the workshop. So with that, I just want to say thank you.